Lesson 2, LEDs. This one's a little frustrating. I will understand if you have some trouble building it. Again, I'm happy to make my code available to you guys as you work through this. In this lesson, they don't explain things that need to be explained, so I'm going to try to explain them in a different way. I built this 2 ways. What they're trying to get through to you are the power of resistors. So I want you to read through this. You're going to pull all of these materials into your simulation, but you're also going to pull in a second copy of those materials minus the Arduino and a 9-volt battery, so I can show you 2 different ways to do this, which may resolve some of the issues you're going to get. LEDs are important to know about. Please read through all this. This is common knowledge you should memorize. I still find this tricky, the positive and negative, but remember that the lip is on the positive cathode. The positive is the side that will receive your energy, and it'll go out the negative way to the grounded. Remember, in real life, the positive LED is longer. Second short, negative shorter. Resistors, read through this area, 1 page. What you really need to know here is the unit of resistance is called the ohm. We went through this a little bit earlier. It's also a kilo ohm and mega ohm. We're going to try out 4 different values of resistor. And this is so we can demonstrate how this gets dimmer or brighter depending on what resistor is used. This code is great to know by heart. One trick is to understand that this reflects the spectrum of colors. And go over this again about the values. I'm trying to keep this video short. Connect up your strip board as shown using the 270 ohm resistor. Go ahead and repeat what I've got here. It's a little tricky looking at this because they don't really identify to you that this is the positive, and the 5 volt is going down this breadboard strip here to feed through this 270 ohm resistor into this positive here, which then grounds out here. See this ground? If you were to zoom in on this a little bit more, this has ground. This completes your circuit. Here's 5 volts of power coming in, and that's where it's going out. So it all stays consistent. What's happening is that 5 volts is too much to go through this little guy. So this is going to squeeze that water pipe down a bit, and then this will light without breaking. The Arduino always gives 5 volts. So how this breadboard is constructed is interesting. Underneath all these dots are lines of copper. On the sides, the lines go down like this for these 2 rows. In the middle, they go across to here and across to here. So essentially, this is 2 different breadboards put together. We could do everything over here in a congested little area, but we're going to use the whole breadboard. And to do so, we have to connect this side to that side, because this little area here breaks the connectivity between these 2 lines. So this goes downward, this goes across, but then everything's broken here down this middle crevasse. So that's why this line jumps over to here, because it's taking the power and feeding this little line of copper here so that it modulates the energy going in, then it gets picked up by the light, and the light jumps over this little crevasse again into the downward strip that's grounded. Now, I have that here. I have 5 volts of energy going into the positive, which is also powering this entire strip here. So in reality, I should have some problems here because I got a 5 volt going in here and a 9 volt going in here. For some reason in the simulator it works. Or it might not, who knows. We'll see later if I've broken it. But then I completed the loop by jumping across that crevasse, because remember, these, if I show you in editing this, if I edit the circuit, it'll be easier for you to see. Okay, this shows you that copper is going down this way and down this way. This copper is going that way, but notice it's not connected to that side. You've got to go across that divide to connect those two. So I'm a bad electrician. I've got a 9-volt and a 5-volt powering the same thing. You never want to do this in real life. And I've got resistors here, and then it's going back to the negative. Now this resistor, this can be before or after this LED, it doesn't matter, because it tempers the entire circuit. When I start the simulation, look at that. This one's a little less bright than this. Well, a couple things going on here. First being, I've got different resistors on here. Second being that this is 9 volts and this is 5 volts. So this is where you start playing. If you make two setups like mine, you can start playing with these resistors and say, okay, I want this to be much more. Wow, look at that, I broke it. Oh no. Okay, I'll go back to less. And I'll put it as 1. Broke it again. Same thing I can do here. I can change the values of this to see if I can make it brighter or break it. I broke both of them. So what that teaches you is the value of understanding your math, so you put the right resistor in place against the 9 volts. What they want you to figure out with that nice mathematical equation we walked through earlier in the semester is what's the proper size of resistor to go here. We'll be going through more of that as it goes. But as you go through this simulation, use the way that I put these things together. It'll be a lot easier on you. I had some trouble when I first did this tutorial because I could not read from here which was the positive and negative on here. So just make yours look like mine.